Hello guys, in this tutorial I'm going to solve a question number 9, paper 31 June 2022. In the diagram we have O, A, B, C, D, E, F, G is a cuboid, which OA is 2. OA is 2, so this side will be 2, this edge will be 2, this edge will be 2. And OC is 4, this one 4, 4, 4, 4, each opposite sides. And OG is 2, 2, this one is 2, this one is 2, this one is 2. So express vectors in terms of I, J, and K. You have to start each from the position, each one from the origin. Origin here is O. It's written, origin is O. So I will start from O. If you move from OA is 2I, from O to C is 4J, from O to G is 2K. Let's start to write the position vector of points which he asked in part A. Express OM and MN in terms of A. I prefer to get the position vector of OM and the position vector of ON, then get the position vector of MN, which is equal to second minus first. So how to move from O to M? From O to M, we can move parallel to J. It's a 2K. Then it's written M is a midpoint of DG. Midpoint, this is a rectangle, it's like this. So this side is 2, this point is midpoint. So this length is 4, so this part will be 2 and 2. So to move the midpoint, we can move 2, then 2 up, or 2 from this side, then 2 down. If we start from O to G, to the half distance of GF, which is 2, then back in direction of I, which is also 2, divided by 1, 2 will be 1. So I will move with 2K, 2K, then 2J, then 1I. It's better to rearrange it according to arrangement of I, J, and K first. It's 1I and 2J and 2K. You can write it as a column vector 1, 2, 2, but he asked to write it in terms of I, J, and K, so keep it. ON, how to move from ON? Where is N first? It's written N on AB, where is the ratio between AN is 3NB. 3NB means 3 to 1, and the whole distance already 4. So this part is 3 units and this part is 1 unit. To move from O to N, we'll first move with 2I, then 3J. 2I and 3J. 2I and 3J. Now, how to get MN? It's ON, 2I plus 3J, minus OM, which is I, plus 2J, plus 2K. Simplify, your answer will be I. Then 3J minus 2J is 1J. Then 3 plus 2 minus 1 will be 1K. 2 minus 1 is 1. Sorry, this is J. And 2K. 2I minus I is 1I. 3J minus 2J is 1J. And minus 2K. This is the final answer. He asked to get LM and MN. Find the vector of equation of the line passing through MN. The vector equation is R is equal to A plus TB. So R is A is start point plus T times B is a vector. So you can use any OM or ON. 1, 2, 2. Let's start with 1, 2, 2 plus T times the vector AM, the line passing through MN. So you can use your answer from part A is MN is 1, 1, and minus 2. Or you can use the second point, which is n, it's also correct. It's a 2 and 3. 2 and 3, 2, 3, 0, plus t times 1, 1, negative 2. You can write it like this. You can write your answer in terms of IJK like this. R is I plus 2J plus 2K plus T times I plus J minus 2K. This is the final answer for the vector equation. Show that the length perpendicular from O to the line M and N is. We have equation already of the line MN, which in part B, MN. And this is the point O, 0, 0, 0. And this is the perpendicular. Let's say the projection when the foot of O to MN at Q. There are 4 steps. You can get Q, but in terms of T, the position vector of Q, which is OQ. The position vector of OQ, write it in terms of T from this equation of the line. We can write it as 1 plus T, 2 plus T, 2 minus 2T. This vector and MN are perpendicular. OQ perpendicular to MN. So the dot product of these two vectors is equal to 0. OQ is 1 plus T, 2 plus T, 2 minus 2T, dot ON, which is 1, 1 minus 2, 1, 1 minus 2. Is equal to 0 form equation. 1 plus T, 2 plus T, if you expand this by this, minus 2 by 2, 4, minus minus is 4T is equal to 0. T plus 4T is 6T. 1 plus 2, 3, 3 minus 4 is negative 1 is equal to 0. So now T is 1 over 6. So OQ as a vector, OQ is, if we substitute by 1 over 6, 1 plus 1 over 6, 1 plus 1 out of 6, 2 plus 2 plus 1 out of 6, 2 minus 2 minus 2 times 1 over 6. 2 times 1 over 6, simplified. 6 over 6 would be 7 over 6, the first part. 2 and 6 is 13 over 6, second part. 2 minus third. 2 minus third is 1 and 2/3. 1 and 2/3. If you write it as improper fraction, will be 5 over 6. So the magnitude of this vector is square root of 7 over 6, the whole squared, plus 13 over 6, the whole squared, plus 5 over 6, the whole squared. Now we'll try to simplify the answer. 7 over 6 all squared will be 49 over 36, plus 13 squared will be 169 over 36, plus 5 squared is 25 out of 36. So the answer 27 over 4, square root 27 over 4. This is 27. Sorry, we have mistaken this calculation. I wrote it here 5 over 6, but it's 5 over 3. 5 over 3. So I will change it here to be 5 over 3. So the final answer after simplified will be 53 over 6. I discovered that because he asked it to show that. So when you revise it, you will get your mistakes. So the final answer exact is a square root of 53 over 6 unit or length unit. This is the exact value. So keep it like this. Thank you.